Hey guys, I hate to be teaching like this, but this is the way it is. So here's what I'm planning on doing the next couple of days is we're gonna get on the Google Meet, talk about what we need to do, and if this doesn't go well today, me sending a video and you guys watching it and figuring out, I'll teach over the whole class. But here's what's gonna happen is we'll meet, discuss any homework answers, and then quick check, take attendance, answer any questions. I'll send you to watch a video, but here's the thing. I will be on the Google Meet the entire class period, so you don't have to worry about, oh gosh, she got off. I will be on the Google Meet the entire class period so that if you need anything, just jump back on the Google Meet, send me a remind, send me a Schoology message, so I can help you as much as I possibly can given these circumstances. Okay, so what we're going to do today is we're going to try to find trigonometric values at any angle. So the thing is, when we usually draw a right triangle, we usually put it in the first quadrant because that's what you're used to doing. That's what we did in geometry, but that's not what always happens. You can have points all over the coordinate plane. Okay, so but I want you to think of it, it's just still a right triangle. So you're going to use your distance formula. So there's your point. So here's my point up here, x comma y. And if you want these notes, you can print them off, or you can just take notes however you want to do it. So we know this distance from here to here, that's y, and my distance from here to here is x. Now, that's just a right triangle, and when we get into trig, we always are going to call our hypotenuse r. So if I'm drawing, to use Pythagorean theorem or distance formula, I'm going to say x squared plus y squared equals r squared, and then I'm going to know that my radius is the square root of x squared plus y squared. Okay, that's just using the Pythagorean theorem, and then the distance formula gain r by itself. All right, so here's how it's going to work. What you'll see me do is you will see me sketch a simple graph, plot a point, and then go from there. Okay, so here's my graph. 9, 12. So if I were to plot the point 9, 12, I would go right 9 down 12. So who cares where it is? There's my point P. Now, when you're drawing your triangle, your angle is always formed by your x-axis, be it positive or negative. Okay? Your angle is always formed by your x-axis. That is important to know. Just like up here, oopsies. Just like up here, it was up there. Okay? Now, we have to label the pieces that we know. So I know that this point is 9, 12. So I know this is 9, it's positive x, and I know that is negative 12 because I went down 12. Now, my suggestion right when you get to here is find that hypotenuse. So you're going to do 9 squared plus negative 12 squared. Make sure that negative's in parentheses. Then take the square root of that. So you should get 225. Square root of 225 is 15. Your radius will always be positive. Make sure you're listening to me when I say that. Your radius will always be positive. Now, all we're doing is we're finding the six trig functions based off this triangle. So here we go. Sine is opposite of hypotenuse. Opposite side is negative 12. Hypotenuse is 15. So negative 12 over 15. 3 goes into both of those, so negative 4/5. Okay? If you know the sine, you know the cosecant, because remember what we do? We just flip it over. So negative 5/4. Okay, cosine, adjacent over hypotenuse. That would be 9 over 15. Again, simplify it. So that is 3/5. Secant, flip your fraction. So 5/3. Tangent, opposite over adjacent. So that's negative 12 over 9. Again, divide them both by 3. So that's negative 4/3. So the cotangent is negative 3/4. Again, we're going to start the next one the exact same way. Draw my coordinates, my coordinate plane. Negative 6, negative 2. Sure, right there. There's my angle. So this is -6. That is -2. Find your radius. So -6 squared plus -2 squared. And then take the square root of that. So that's going to be 2 square roots of 10 because you get the square root of 40. And remember, you break down 40. So 2 and 20, 2 and 10. Circular pairs goes out. Whatever doesn't, you can break that down again. Whatever doesn't get circled stays underneath. Hopefully we remember that. Again, that's something if you forget, come back and ask me on that Google Meet, and I'm totally happy to help you. So sine, opposite over hypotenuse. So that's -2 over 2 square root of 10. Well, the 2's will cancel, so you're going to have -1 over the square root of 10. And remember, we talked about this last week. We need to rationalize it, so it becomes negative radical 10 over 10. We did that with right triangles. There's your sine. Cosecant, flip this one right here. So negative radical 10. Cosine. Cosine is adjacent over hypotenuse. So it starts with -6 over 2 square roots of 10. -2 goes into -6 3 times, so -3 over the square root of 10. Rationalize it. -3 radical 10 over 10. So the secant is negative radical 10 over 3. Okay? Tangent is your last one. Tangent. Opposite over adjacent. So that's -2 over -6, which is 1/3. Cotangent is then 3. So it's all about drawing your triangles. Now, when we get to unit circle and we get to reference angles, I am going to make it very clear that you are going to want to remember what I tell you right now. You have 4 quadrants, okay? You have sine, cosine, tangent, and all, okay? So everything in quadrant 1 is positive. This is where things are positive, okay? So everything everything's positive in quadrant 1. In quadrant 2, some of you hopefully remember this from last year. In quadrant 2, sine is positive. In quadrant 3, tangent. And in quadrant 4 is cosine. This is really important. That's going to make your reference angle so much easier if you know that, okay? So if cosine is positive, so we go, which 2 quadrants cosine positive? Well, I know it's positive 4. I know it's positive in 1 because everything's positive in 1. So that's 1 and 4. Where could the terminal side be? It could be in quadrant 1 or it could be in quadrant 4. We don't know. That's okay. If tangent is less than 0, which means tangent is negative, okay? Can't be in 1 because everything's positive. Can't be in 3 because that's where tangent's positive. So it's going to be either be in 2, or 4. Okay? Secant. Secant goes with cosine. Don't forget that secant is not cosine. So if secant is less than 0, that goes where cosine is less than 0. So where's cosine negative? Cosine is not negative in 1. It could be negative in 2. It could be negative in 3. It cannot be negative in 4 because cosine is positive. Now we're going to put a couple of them together. If sine is less than 0, so where is sine negative? So that's going to be 3 and 4. And cotangent is positive. Remember, cotangent goes with tangent. So it can only be in quadrant 3 because that's the only quadrant that they both match. Okay? Again, if that went too fast or if you need help, jump back on the Google Meet. Now, what's going to happen here is I'm going to give you what I know is true, sine, cosine, or tangent, and I'm going to tell you another piece. So what I will do is I will label what I know. So in this case, sine is positive, so that means it's in quadrant 1 or quadrant 2. And tangent is less than 0, which means it's negative. So that means it has to be in quadrant 2 or quadrant 4. Now, which quadrant's the same here? So that's quadrant 2. So when I draw my triangle, make sure it's in quadrant 2. And make sure you're labeling where your angle is immediately. And remember, that angle has to lie on your x-axis. Now we're going to use what we're given. We're given that the sine is 8 over 17. And by definition, sine is opposite over hypotenuse. We know that to be true. I don't know why my 8s are being so weird. Sorry, guys. Okay, 8 over 17. I need to find all the other trig values, so I might as well just reverse Pythagorean theorem. So 17 squared minus 8 squared, and take the square root of that. So this is, it's going to kick out 15 in your calculator, but this is on the negative x-axis, so that has to be a negative 15. That's really, 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 really important. Okay? Now, from here, I already know sine. I know sine, so that means I need cosecant. I need cosine. I don't know why that's being so bad. Secant. Tangent. Sorry, that's so awful, guys. And cotangent. All right, now I find cosecant by flipping sine, so that's going to be 17 over 8. Cosine, adjacent over hypotenuse, so negative 15 over 17. Secant, flip it, negative 17 over 15. Tangent, opposite over adjacent, so negative 8 over 15. And cotangent is negative 15 over 8. Man. I'm sorry this is so bad. I don't know why it's so awful right now. Okay. Let's do another example. All right. Cotangent is negative. Cotangent is negative. And secant is positive. So cotangent is negative, is in, I'm going to flip this around, see if that helps. Cotangent is negative in 2 and 4. Secant, remember secant goes with cosine. Secant is positive in 1 and 4. So which one's the same as quadrant 4? So there we go. Now cotangent is negative 4, so that means the tangent, oh my gosh. Sorry that this is so bad, guys. I don't know why it's being so awful. It's really being crazy right now. The tangent, I just have to type. The tangent is that flipped. So my tangent is negative 1/4. Okay? So tangent is opposite over adjacent. Now, you'll notice I did not label that one negative immediately or the 4 negative immediately. So you have to look which one's on the negative side. This is a positive x-axis. This is a negative y, so that has to be a negative. Now you're going to use Pythagorean theorem. 4 squared is 16. 1 squared is 1. So that's a square root of 17. Okay? Now, the sine. Opposite over hypotenuse. So negative 1 over square root of 17. Rationalize that denominator. So negative radical 17 over 17. Cosecant, which clearly you can't read. Flip that second one, is negative radical 17. That says cosine. No, you can't read it. No idea what's going on. Cosine. Cosine is adjacent over hypotenuse. So that's 4 over the square root of 17. So rationalize it. So that's 4 square root of 17 over 17. So then your secant, you flip it, square root of 17 over 4. Okay, like I said, if you have any questions, get back on the live, just ask me. I will talk to you guys later. Bye.